The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our 30-minute free training session for today's SolidCAM Live. With me every Monday and Friday this month is Kevin Rakel. Hey, Kevin.
Hey, how's it going?
So today we're actually doing what I would kind of consider what we normally do on a day-to-day in the tech support side and training side. We're going to take a kind of more of a tech support question and turn it into a training session because we're going to flush out the answer a little bit. But basically, I got an email from Brian, one of our regulars on SolidCAM Live, and here's a snippet from his email. The toolpath, for some reason, is treating the part as having 3 islands in quotations, even though it's a large flat face. So the question is there some way to tell it, hey, it's one big island, run all your wavy loops full length? I kind of paraphrase there a little bit, add a little bit of a color on there, but basically what he's talking about is you have this 2D iMachining toolpath. Why is it doing it in 3 sections like that? And the simple answer is this is pure iMachining. When you're looking at this, this is exactly what iMachining is looking to do. It's going to take a pocket like you have here. Now this is open on all edges, and I didn't even have to open up the toolpath to know that because I can see that it's going over the edges there. And we have this side entry rather than trying to helical entry in the center there. So we know that this is open on all edges. We also kind of know that if we take a look at the part and we were to use the new functionality in 2020, if I were to click on that top face, it would set all those edges as open anyway. So that's kind of why we know it's going to do this. Now, what we're looking at here is 3 morphing spirals, those 3 islands that Brian's talking about, and 2 separation channels. If we were to do solid verify, we would see that it's going to try and wiggle its way through here, wiggle its way through there, and then work its way to the center of that, work its way to the center of that, work its way to the center of that. That is pure iMachining right there. That is the island moding of iMachining. So you've got separation channel, you got morphing spiral. If there was a sharp corner, we would see the D-slot tricoidal. So we got 2 out of the 3 characteristics of iMachining. Now, to answer, like I said, this is kind of more of a tech support question that we're going to do more like a training. So my answer to Brian would be, if we suppress this and take a look at the copy that I made of his toolpath, while this opens up, in the technology section, under channels, originally it would have had, by default, island moding on, and it would have given us those 3 islands. And the modes would have been that separation channel. With island moding off, all we have to do is save and calculate, and we no longer get separation channels. We do get a little bit of a separation, but more on the side of it's not trying to do it as islands. What it does is it's going to work its way across this thing, work its way across this thing to get that one central island. And lastly, if you wanted to do it as the full length, what we could do is this guy right here. This is, again, a copy of the original toolpath. What I've done is kind of what you see already going on there with the wireframe. I still have island moding on, but I've told it that it's closed on the 3 edges. So I'm not actually using the functionality of selecting face or anything like that. I've actually done it with the classical mode here. And I gave it 1 open edge, but then I gave it a negative offset on all sides, meaning that it thinks that the pocket is actually larger than that top face. This is the kind of thing you would have done with maybe an old pocketing toolpath. You would have kind of given it some negative offset just to kind of make it wander outside the edges a little bit. So essentially, these are still closed in terms of the geometry, but I'm telling the toolpath to go further outside there.
And for those that, and before you show that path, I just want to explain something here. For that modified geometry, so for in the past, what you guys would have to do to accommodate this is you would actually have to draw its own sketch. That is the tool diameter and bigger. Well, now with 2020, you guys have the option in there to do a negative offset by feature request by you guys, and now you can do that in there for you.
Yep, absolutely. And I did it on all chains, but we could have easily have selected each chain and then, or gone to advanced modify and actually given it different offsets on each edge. Right, Kevin?
Yep, absolutely.
Okay. But I did it all in one, just kind of, to make it simple. But basically, that is right there. Like that. Let's see if I can get that shading off, get this out of the way. And you can see now that it's still doing that outside contour, that outside entry, no longer helical entry because it still has an open edge, but it's going back and forth. And basically what this is D-slot tricoidal in the corner, even though it's not really necessary, but you can see it's doing D-slot tricoidal, and it's doing a really large separation channel. It's not really a separation channel because there's no islands, but it's doing that long, along the length of the part. So basically what what Brian's asking for in the end of his email there, it's one big island. We're just doing it as big sweeps across. It still uses iMachining. It's still giving us that reduction of the retraction, as you see there. Still material engagement control, all of that, but it's doing it in one big swoop, like you would see in maybe like a large separation channel. Okay, so Kevin, what would you add to that?
Yeah, and go ahead and unsuppress that first one, Mark. And let's show that path. We don't have to open up the operation, but if we just show the path.
Okay.
And what I wanted to kind of tell you guys in here is, so basically the why. Why is it doing it this way versus long passes? Well, what built into the algorithm, it is seeing it as, and maybe Mark, if I could have mouse control,
yep.
I think you can at least point.
You have control.
So basically, if we had this path off and we just had a bunch of lines going this way and then a short line and then another long line, what's happening here is we're having one long tool path and then a real short tool path and another long one again. Plus, as we're going along this long path, there's more and more heat that can get built up in there, in that chip and in the part and all that. So by switching it over and within the algorithm to breaking it up into basically 3 equal squares, what we're doing is we're keeping in constant contact with that material, and we're not doing the long drawn out steps and then a quick little short step, then a long drawn out again and a short step. We're over here, that is just staying in constant contact with that material, and you guys should actually see a faster cycle time using this way right here versus coming over here.
The very last one.
And doing this path right here. Now it looks like, you know, it wouldn't be, but you know, it all depends on the material too. But all these long drawn out passes right here and then moving back over is going to be eat up more cycle time than it would be using a separation channel by default. So what we're trying to do is make it into iMachining with the algorithm. We're trying to make it into as many equal squares as possible so that tool can stay in constant contact, just doing a nice spiral to really make that cycle time more efficient. Plus the chip control is, you know, you can see, you know, over here to here, our tool path actually changes up based off of that tool control that's going on there. So that's the reason why they switch it. You know, by default, the island moding is on, and the built-in algorithm there is to set up the separation channels.
So then the question would come up with that third tool path. You were saying that the long passes might heat up the part a little bit or heat up the tool a little bit. So why would this even be possible? And is that because the iMachining is actually controlling it in this aspect as well, but we've given it that additional constraint of those 3 walls?
Yep. Plus the additional constraint. And that's and the reason why we're actually getting this path this way and not getting the island or the island separation in there is because of, we told it we're basically forcing its hand in there. So we can manipulate the path in iMachining even though that with the algorithm turned on, but this way is going to take a little bit more work on your end, but you'll actually have just a little bit longer of a cycle time, but your tool life would still be just as good as, you know, as our first one, but you just have a more efficient path where, because if you count up each one of these lines that's going along here has a full retract over. So we're going along here, full retract over, versus for over here, we have very little, short little retracts coming in here as it's doing the D-slot tricoidal in there to get that material. But then once we actually get into the material, it's just staying in constant contact. So
So it kind of goes with what we normally talk about whenever we do training on 2D iMachining. The more information you give the software, the better off you'll be in terms of optimization. So one of those bits of information would be the limits that you have. So those 3 walls generated a toolpath that goes along the length. Like Kevin was saying, that's probably going to increase a little bit of the material engagement considerations, but it's the limit of your toolpath. It's the limit of your situation with this part. So it has to do that. Whereas here, we've given it all kinds of freedom. It can go outside the chain, and we've given it the ability to do island moding. So it, like Kevin said, this might actually give you a better cycle time, better material engagement, better tool life, just because of all that freedom it has. Whereas with the other toolpath, the third one, it's got those 3 walls it has to account for.
Yeah. And if another way for Brian, if you wanted to kind of do that long pass in there, what you could do is come to the 2D side of things, do a pocket, and then we'll grab our geometry, switch over here, grab a tool. And then in technology, just make sure we're set to oh, hang on, I got this, put it. So now if we go to our technology, we could, why can I not get patch turned on?
Yeah, so that is because that's actually something that we talked about. I don't remember if it was in SolidCAM Live or it was internally, but this is actually a new default from 2020 where as soon as you've got open edges, open pocket, it defaults to that use profile strategy. So now you should have access to technology once you turn off that profile strategy.
So then come in here, hatch, and then we'll do our corners as fillet. And now this will kind of get you up, you know, maybe this is the more of the path that you're looking for, but it's coming in there just doing a nice little zigzag with the radiuses in there as well. But it's not iMachining, so you would have to calculate those feeds and speeds for you as well. But
that actually leads into kind of a really common discussion we always have. Now, because this is only doing the first 25 thou of that part, would you agree, Kevin, that maybe pocketing would be the better toolpath for that? It's only just 25 thou.
Yeah, if we're taking light cuts, you know, just a very skim cut, to be honest with you, a pocket operation is going to be faster for you than doing iMachining.
Because I think we've mentioned it once before, but my usual rule of thumb is how many depths of cut. So if there's 1, then pocketing is the better one, because all those arc movements, all that island moding, that separation channel for sure, that's going to eat up a lot of cycle time. And because it's so little depth, you're not really getting the benefit of that material engagement from iMachining. Whereas if you do it as pocketing, like you see here, that's a very simple tool path. It's going in the long direction along the length of that part, but that cycle time is much, much less than what you're going to get with just a skim cut of your 2D iMachining.
Yeah,
and
we'll actually might be able to even see that in the iMachining operation itself. I thought I clicked it. A little bit of lag going from Minnesota to Canada.
Yeah, we often joke that you got to get the hamster in gear, but I think up here I got to find a substitute for the hamster. Maybe a beaver or something.
Yeah, go with a cow. Okay, so we can see right here that iMachining is telling us that this tool is not the ideal tool for that cut. And that's just because we're taking such a light little skim cut on here that we're in red right now. So, you know, in that particular case, you know, since it is such a small little skim cut on there, definitely do a pocket operation or even a face mill operation would be a more ideal route to go. And I guess we could kind of lead off of that a little bit as the different colors in here that populate. I don't think we've ever kind of talked about that, have we, Mark?
Not in SolidCAM Live, but I know we've talked about it in KevCam for sure. When you did the KevCam on 2D iMachining, that was something that was brought up. And I do bring it up every once in a while in anytime I'm talking about iMachining with someone in training, personalized training, or I think I might have mentioned it in the 2D training video as well on YouTube.
Okay. Do you want to explain it here or you want me to?
Uh, so basically, it's like Kevin said, this is not that it's wrong. This is just how efficiently we're using this tool. So if we take a look at the tool definition, under tool data, we have a cutting length on this tool of 2 inches. Now, if we're only really doing, in this case, that 4/10, there is really only a small percentage of the flute engaged with the material. That's what ACP is actually telling us. ACP is actual or axial, I guess is you could call it as well, contact points on the flute. So when you define your tool, you define it with a certain number of flutes, you define it with a flute length, you define it with a helical angle as well. So if you are actually, if you've got a number of flutes and it's at a certain helical angle, iMachining will actually calculate, yeah, it looks like Kevin's responding to Brian's note there. There is only 25 thou there. So that Technology Wizard readout should actually be 25 thou. But what that's going to basically do is give us the same sort of thing. Once Kevin clicks on Technology Wizard, it's still red because even though we're machining that first 25 thou, it's still not a lot of material. Actually, it's given us a better ACP. So we actually got some numbers on the board here so we can take a look. So about 4% of the time, that flute, that single flute, is engaging that material. That means there's 4% of the time there's a contact point with that flute, single contact point with that flute and that material. If we were machining something that was 2 inches deep or more, then we would actually see a higher ACP, and that means that it's more efficient. We might have a whole number there. We might have 1.04 or 2 or 3, whatever number of points you have. Once you have whole points, that essentially represents that there is always a point of contact between the flute and the material. That means you're efficiently using that tool to machine this material. And the colors reflect that. So forget about the numbers for a second. Let's say you wanted to just take a look at this window real quick and figure out if you were using this tool effectively. iMachining is all about optimization. So if you just take a quick look at this, maybe you didn't even know what ACP was. But generally, we look at red as not good. In this case, it just means it's inefficient. Since it's a low ACP, gives us the red color, it's not the best use of the tool. If we wanted to, we could switch to a different tool, maybe optimize the use of the tool a little bit more. But in this case, again, because it's so shallow, we really wouldn't be using iMachining anyway. It's overall just going to be inefficient. Unless you had a really small diameter tool, really small flute, and then maybe you're optimizing the use of this tiny ass tool. But
well, let's try out of curiosity. So like Mark's talking about, it's all based off of flutes and all that stuff, but let's go over to IData. And right now, darn it, we're using it in 2 different operations. So I'm just going to make a copy of this tool.
So basically, just to finish off the colors. So the other colors would represent that level of efficiency. So while Kevin's copying this tool, if in that same bar you saw a yellow color, then it's mid-efficiency. It's a good use of the tool, but it's not fully optimized. When you get that green color, that's the best use of the tool. It's figured out the best way to use that tool, fees and speeds, the step down, all that material engagement is going to be used to the best of the ability of that tool. So when you see that green color, it's green means go, basically. It's a really good use of the tool.
Yeah, so the green is going to be your optimal cycle time, optimal tool life, all that stuff. Red will still cut, but it might not get as good a tool life. Same thing with yellow. So what I did is I switched it over to a 60-degree high helix, and let's see if we can get this turned up. So now that brought us up to a 0.7 here. And we really want to be, something one point something or higher is what we're looking for. So, and you guys can kind of play around with this and find out if that tool is going to be ideal for the job, or before you even buy the tooling, you can come in here and tell it. So maybe let's switch it over to 8 flutes and see what we're looking at. So we're slowly climbing. Unfortunately, it's such a small little cut. Let's just
well, maybe go to levels and just increase the levels, just so we can see how that kind of affects it as well.
Oh, sure.
Just to get the color coding in there. So in the level section, we can just say that from the upper level of, I don't know, 1 inch.
Let's just do 200 thou. So we're getting there. Brian said do half the diameter. I mean, what what diameter are we running here? So 1 inch, so if we did 1/2 inch. And we could get that tool to be ideal, but it's like Mark said, it's going to be really small, a lot of flutes just because it's such a light little cut in there. So now we're getting into the yellow range. So now, I mean, we can add a different, smaller tool in there. We can go with more flutes. Just to kind of show you guys, if I kick this up to not a realistic tool, but if I'm trying to play around in here and we say 16 flutes, oh, we're still not in the yellow. So it's still not the ideal tool for the cut, even though we have 18 flutes. But it's just letting us know that, you know, this is a good way to come in here and as you're bidding out a job and maybe you're kind of pre-programming this and what tools should I order for this particular job.
No, even at 2 inch, it's still, we're getting a really good ACP, but even then we're still fully engaging, but yeah, still not the, well, I mean, like I said, yellow is mid-range. It's probably on the upper range because we're getting 17 ACP. So I'm not sure why it's not green yet, but it could just be that, but we, there's so many parameters in here. It's one of those math equations that is like super long that whatever is calculating in the back there, when you see that yellow, you're good. When you see the green, you're even better. But yellow, red, green, whatever color you're getting, you're still getting that iMachining. Oh, there we go. Okay.
So
I looked away for a second. I didn't see what you changed.
I had too many flutes in there, so I switched it over from I put it at like a 5 flute, which would be a normal end mill, and then put our IData with a helix angle at 45-degree helix. So if we were actually to cut this part, you know, and we had a 1 inch deep pocket, that's telling us that, all right, this 1 inch tool with the 45-degree helix with 5 flute is going to be the perfect tool for that job. And it's telling us right there. And it may look weird because our ACP is actually lower, but it's all, like Mark was saying, it's all built into the algorithm for you guys, so you don't have to do that guesswork on what's the ideal tool for that. So
yep.
Hopefully that kind of helps out for, well, one for Brian on why I was doing it straight cuts, but two, as for everyone else, giving a little bit more of an understanding on the coloring and the ACP values that are in there.
Yeah, and just to cap it off a little bit, the color doesn't change with this, right? Because it's irrespective of the feed-in speed. It's more to do with the geometry of the tool itself.
Yep.
Number of flutes and step down and all that. But yeah, it's like Kevin said, this is more of a overall how to use iMachining kind of benefit, not just for this particular part. And sorry, Kevin, go ahead.
Maybe in Brian's aspect, he doesn't want to take it all in one cut, or maybe it's taking kind of too much. He ran it through and he did it in, you know, something didn't work out right. Well, he wants to take it in 5 steps now. You guys can manually type in here 5 steps and it will do it in 5 steps for you. So I've seen a lot of customers come in here, they go to their tool and they change their cutting length to tell it, to kind of lie to the program and tell it that, well, instead of having a cutting length of 2 inches, I only have a cutting length of 1/2 inch because they want to take 1/2 inch passes. Well, you guys don't have to do that because that's one, it's going to kind of mess up your setup sheets unless you know that you're doing it. But you can come right over to the technology wizard, switch it over to user defined, and I can type in whatever value I want in there, and it's telling me right now with doing 5 steps, I'm doing a 400th step down. So maybe if I want to do 4 steps, oops.
I would actually say you probably don't want to do that even more so, because if you are tricking it into the geometry of the tool, that's going to mess up some of the material engagement calculations as well. So if you do have that 2 inch depth of cut with a certain flute length, helical angle, define that as is, and then, like Kevin's saying, come here and give it the step down. Because if it knows what tool you're actually using, it can better optimize and safely calculate those feed-in speeds. If you tell it that it only has a 1/2 inch, then it's going to think the flute length is only so much. It's going to think that the helical angle is only so much. You want to give it accurate information so it calculates as accurately as possible.
Yep.
Okay, so hopefully that answers Brian's question and any other questions anyone has on iMachining. If you do have any further questions or any comments or even suggestions for what we should cover in SolidCAM Live, I haven't put my email in there, so hopefully Kevin puts the email in there, or I have to jump into my thing here to get. All right, put it in there. So I'll do the finishing. So Kevin's going to put my email in the chat section. If you have any questions, comments, suggestions for a future class, please, you can use that email to send me your parts, your questions, your comments, and we'll use that in a future SolidCAM Live class. If you're looking for your own personalized training, you can use that email as well to contact me with the day and time that you're free. And personalized training essentially is just you and me in a GoToMeeting using the phone so you can actually talk to me live and asking your questions live. And it could be any questions you have, any topic you'd like to go over. If you've got a part you need a little bit of help with, you can use your personalized training for that as well. And if it's some sort of proprietary part or confidential part, high class, you know, top security level kind of part, I don't mind getting the bosses to sign something. If it is confidential proprietary, there's no issue because the GoToMeeting is only between you and I. So if you need anything signed on a corporate level, we can easily do that. If you know anybody that can benefit from SolidCAM, just give them our contact info or get them to contact us. And if it goes into a demo during this SolidCAM Live period, you get a $100 gift card if they go to demo, just to sit in a demo. They don't have to buy at that point. But if they do buy, you get 20% of that sale. And that goes even past SolidCAM Live. So you get 20% of a sale just for helping us to sell SolidCAM. So that's a good chunk of money just to get SolidCAM in the hands of someone that you know could use it. I mentioned it at the top of the class. This is the new slot of classes. We're doing them every Monday and every Friday of August. And so that you've got lots of time to send us your questions, your comments, and what we'll do is we'll pile them up for another class, and then we can kind of do them all in one class. These are still being recorded, even if they're only Monday and Friday, they're still being recorded, and they will be uploaded to YouTube as soon as Kevin gets a chance to translate them and put them on YouTube. All the previous classes are on YouTube as well. So if you missed one in the last couple of months or you're looking for something specific, you can always go to the YouTube channel, do a keyword search, and find that topic that you're looking for. That's a great way to get some offline, outside of regular business hours help. But you can always call us on the main tech line as well if you're in North America. If you're part of the international customer group, you can contact your local resellers for help on that as well. We'll be doing this every day, not every day, every Monday and Friday until the end of August. So you have your chance to send us your questions, comments, and suggestions. But for today, we'll end it here. Hopefully everyone is still safe. So keep yourself safe, keep your family safe. I guess keep busy. Everyone's back to work, so everyone's busy, but keep busy. Let's build both Canada and US. Let's get our economies back up and running. So everybody stay safe. Talk to you on Friday.
All right. See you, everyone. Bye-bye.